overlap to. Yeah, this is tricky. M in entity velocity equals 0. I can't do that, of course. I would need to give it a y. So this stops it. Maybe... well, this is what I can do. If it collides on the top, so if it collides on the top, and this is relative to the effect entity, I need to draw. Okay, so this is effect, and this is the mic. This is the voice object. This is a collision on the top of the voice object. So in this case, we want it to continue the downwards motion, which is negative y velocity. Right. Does that make sense? Yeah, so if it collides on the top, we do that. Wait. What? No, I want to do an if. You know what? This loop isn't going to help us so much. Yeah, we just want to do something like this. Then we want negative, what was that called? K input pixels per second? Yep. Right. If it happens to collide on the bottom, well then, and yes, we could do some tricky thing here. What I mean by that is, convert this mask to a value that we could multiply against some number to do negative, positive. But all we're going to do is use an else if for now. And I do apologize. Okay, so this kind of thing will just be repeated like that. And when you collide on the left, you want to, that means you have something on your left and you want it to keep moving to the right. So that would be like that. Yeah, does that make sense? And if it's wrong, it'll be obviously wrong and we can easily fix it. Okay. Other thing we might want to do is adjust the position so that if it's overlapping with us, we fix it. But for now I'm going to leave that. That's for the next step. So now I have a valid velocity. I would like to update. So is there an update call here? There's probably no update call. Yeah, so we will need an update call. There's no update call in Mini. Yeah, so our update call is actually going to use mostly To do most of the work, it'll call the super update call. And these are all sound calls, so I'll keep them together. Yeah. So the update position was time step. First thing off the bat, we do the super. Like so. Then we want to do we want to update the voice entity, and this is a little bit tricky. We are not just updating by moving the velocity, we're talking about shrinking the object by a certain amount. And this is the actual amount we want to shrink by. Now let me recall how the size works. I believe the size is not like a radius. So when I say x is 0.5, I don't mean, that means from left to right the object spans 0.5 units. They're not pixels, but whatever. Oh, that's another thing. These aren't pixels. Yeah, but anyway, we can call that for now. So I just have to subtract this from the size pretty much, and that will be pretty good. Anything else? Yeah, I subtract that from the size, and I take off from the tail end. I want to subtract from the size and take off from the tail ends, right? Because this is moving up. I want to make it, this is the amount of size I have to subtract from y. And then I have to move the position up this amount. So that's actually quite easy. Let's try and do that. M input, it's just in entity. It's just in entity, isn't it? Yeah. M in entity plus. So we can actually use our filter, our vector addition, and that is just addition we want. So that will look like, and probably there's some good examples here. Oops. In our normal physics, this is where we're using most of the vector math. So here they do it. This is friction. But for the velocity scaling, yeah, you scale velocity by a time step, add it to the position. Simple. So let's just do that. Filter vec3 dp, and this stands for delta position. So let's compute that. In fact, we don't need to do anything, and we can just copy and paste this and just update it a little bit. So time steps there. However, we're talking about m in entity, so we need to put that there, like that, and like that. Yeah, so this will give us our new position. We haven't shrunk the object yet, but we can do that anytime because nothing depends on the size. So what we do is, is the size just a filter vec? Yeah, it is just filter vec 3. So what we do is the same thing for the size. Filter vec. Yeah, in fact, we shrink it. Let me think about that. So what did we do here? We did the upward movement with velocity. But the size gets smaller regardless if it's positive or negative. Yes. That is a little tricky, isn't it? Yes, that is tricky. This is what we can do. We have DP. Yeah. So let's make the comment. Move the entity's position. Now shrink the entity so that it is adjacent to the edge of us. Shrinking always means negative delta. Okay. So it doesn't matter if we're going up or down, but the size will get smaller no matter what. So that means we can just take, I wonder if I have an abs function. I don't think I would have that. Yeah, there's a norm function. Okay, so we get to add a library call. Well, to call a library is one thing, but we'll just say void filter abs filter vec abs. And that we just take, you know, the normal filter vec3 filter vec3. The reason I take in and out is sometimes you don't want to modify the basic and the input, and it doesn't matter. It costs the same. And why is this tabbing forward? Yeah, because that's, yeah. So let's put it on the bottom. Yeah, like you can see here, in the norm, it's just going to look like this. Out dot, or out x equals in x. We have to do a fabs. I don't know if there's something faster. It's actually tricky to, you could just, I'm sure the fabs just drops the bit for you. Comparison drops it or something. So it's nice because we don't have to worry about that. So let's copy and paste this. Oops. So like that. I wonder if it's just abs. No, I think it's fabs. Yeah. And we don't check. We just hope that the people calling this check, because this is just a fast math class. Right, so if you pass the same thing for in and out, you'll get an absolute on that guy. So what you can do here is filter vec abs and dp and dp. And then we want to add to the size. Yeah, and we're not modifying velocity, so this will be constant with time. Time step will vary each time, but it should work out. So that might be it. Eventually the size will equal 0, or a negative value. So that's when we want to remove the vector, the entity. When the size drops below 0, you know what? I just made this positive. I don't think I will need a negate. Will I need a negate? Yeah, it might be. It sounds like a cool function. Let's do it. Oh, did I edit something over there?